I'm going to uh, talk to you guys today about um, some broiler stuff and then ducks lighting. And a lot of people, in my experience, when I've been out there in the duck industry, a lot of the stuff they do, unfortunately, is based on broiler data. They go out there and they look at what the research is in the broiler world because there isn't a lot, and I'll go over that in ducks. So they've been trying to figure out what to do in ducks when they a lot of times mistakenly are applying a lot of broiler research. So that's what we're talking about today. So of course, why this is becoming important, we all know that poultry consumption worldwide is going up. We know that the meat birds, turkeys we just talked about is going up some. Chicken especially is going up, but in certain areas of the world, as a lot of you on this are from the international world, there's a lot of duck, maybe not in the United States and America, as you can see here, a lot of duck consumption, but worldwide, especially in Asia, it is a large proportion of the poultry meat that is being consumed. So as the world is becoming more concerned about welfare and other aspects, duck world is now industry is now having to look more about their practices and try and see how to optimize those. And it's playing, as I said, a little bit of catch up with some of the other industries out there that have been doing it a little longer. But as you got from Karen's talk this morning, when we talk about poultry and we talk about what's important for their management, a lot of this comes from one of the breed guides showing that they even show that it's important. You talk about a lot of things like nutrition, temperature, water supply, health of the birds, how they're feed, ventilation, stocking density, all that stuff. But one of the factors that sometimes is not necessarily thought about is the lighting program, because lighting can greatly impact all of those factors, the growth of the bird, the health of the bird, its efficiency, converting that feed into growth. All those different things are going to be there, as well as their welfare is going to be affected. So lighting, no matter what species we're talking about, we're talking about different ones today, is always very important. It's one of those critical factors, which I'm glad a lot of you have come here to hear about today, that we need to really focus on and figure out what's going on and what is the optimal conditions for those birds, whether we're going to talk about photoperiod, intensity, wavelengths, flicker, all those different things that happen there. We need to kind of, because birds perceive the world a totally different way than we do. Their eyes, as Karen mentioned, and things like that are very different than ours, how they perceive all that stuff. So we need to know that and not just go by what we think is good. And that's kind of going on. So the perception of light in poultry, again, affects a lot of things, as I just mentioned. It modulates their endocrine system, their circadian rhythms, as we just heard from Karen talk about that as a major thing that birds are very affected by the light on that. It affects their behaviors in general. You can cause lots of issues. You can also solve some of the issues with lighting program by changing certain lighting to reduce certain problem behaviors or other problems, or increase activity, decrease activity. Doing that because it's going in there, affecting all those different things, as I said, circadian rhythms, activity, their visual perception, their hormones. There's even some stuff saying that obviously with lighting affecting different aspects of hormones and other parts, that you may be actually affecting their fear and their behavior and their even their moods. We don't really can't ask the chicken what their mood is, but we can think that maybe that's causing them to be more aggressive or less aggressive or things like that, depending on the lighting that they're in. The reason that is, again, is, and this may be talked about earlier, I missed the first 3 minutes of Karen's talk, so hopefully if it is review, you guys get another review here beating it into you. But letting in mind, again, because of that, the reason it's different is because birds have more modalities to sense light than we do, because of the fact that they have a pineal gland that is close to the surface of their skull, that their skulls are thin enough that the light can pass through there and stimulate their pineal glands with light and affect their rhythms and things like that more than ours. They also have their retinal photoreceptors similar to that we have photoreceptors, but they also have deep brain because, again, their skulls are thin. That light is passing through there and actually going into photoreceptors that are in their hypothalamus, or and there's also some in their lateral septum area. Those are also being stimulated, affecting reproduction and other things as well. And there's different photoreceptors for different types of light, obviously, because different light is going to get filtered as it goes through your skull and through tissues, bone tissues and brain tissue and all that, to get to these areas versus just going straight into your retina. So you're going to get different types of stimulation, different control over those. So birds are going to perceive light much differently than we do. And we need to kind of take that into consideration as well when we're thinking about lighting types and photo periods and all those things. And we need to think about the birds themselves and not necessarily thinking about how, as historically, a lot of it has been how we just think what they need. Again, the reason that is because they have different rods and cones than we do as well. Might have been talked about. They are tetrachromatic. So they had those 4 areas of light that they different thing that more than we do. They have these different oil droplets and things on their cones than we do. So they can feel that there. They also have we haven't talked about it a lot, but they also have a fifth code that will pick up movement because they are a prey species. Um, so they need to be. So that's another thing we need to consider. That that's why when there's fast movement in a barn, they may be more susceptible to that. So things like that, fast movement, are also something that we need to be considerate of the birds having changes, shadows going over things like that that could startle them. Those are all possible things that we need to consider when we're talking about birds and in general. So generally, some people, you ask questions about different types of light, and I'm just going to, so generally there's the types that are out there. A few other types of out there, obviously high pressure sodium, some other ones, but the main sources of light that a lot of people have used over the year in poultry industry, we all started out, I mean, incandescents were very popular, maybe still used in certain parts of the world, at least here in the US and other parts of the world, they are now being phased out because of the lack of energy efficiency and things like that. But historically, when you look at those light bulbs under a spectrum, you see there's a whole lot of red light perceived there. And I'm going to show you in the next few slides perception of birds into the different wavelengths. But that becomes important because when we've been raising them under there, a lot of the historic data that we have on that is based on the fact that those birds were actually perceiving a lot more red light in those than maybe when some of the other methods that now we're using. So compact fluorescence, this is just one compact fluorescent. They all give out different ones. She'll say that whatever light bulb you're using, some of them may have this more of a green peak like this, while other ones may not have that green peak and have more red peaks in them. It really depends on the level of what gases they have in them burning, what is giving out the light. But the birds are going to perceive all these different peaks here. Just as an anecdotal thing that I saw that affected birds in different bird layers. I was working with a commercial group once that they switched their compact fluorescence in their barn because they had a better deal they had to replace bulbs, and they got a deal on a certain type of bulb, and they put them in there, and then they saw their egg production basically drop dramatically. So I went out there, they asked me to come do them, and I used my little handheld spectrometer to look at it, and I saw they had this huge green peak, and I talked to them about it. I said, compared to their other barns, and I said, well, I think this light bulb may have too much green light and not enough yellow red light in there so that when they switched back, they took my advice and they switched back to their old bulbs, and their production came right back up. So it showed that the bulb wavelength can affect a lot of things different in birds, and sometimes we not think about it because we're thinking, oh, it's giving out the same quote level of light because it may be rated at the same Kelvin as the light bulb, but it's actually what's making up that Kelvin could also affect it. And that goes along with the light emitting diodes, the LEDs as well. You can make those be whatever you want. And some companies put a lot more certain colors, yellows or reds in it. Some put more blues in it. Different things. They're all going to have this little blue peak in them, unfortunately, because my understanding from talking to LED companies is it's one of the cheaper LEDs to make, so they can put a lot of those in there to increase their intensity. So just for increasing light intensity, you're going to have a lot of blue light, unfortunately, in there. But we switch into those. A lot of, at least in the North America, I've seen a lot of movement towards LEDs, even moving away from compact fluorescence for a lot of reasons. But unfortunately, more recently, the research is focused on this. But a lot of the old researchers, I'll keep saying, is it's based on these stuff here. And while Karen said it does not affect probably when you're looking at photoperiod, because I think photoperiod is a very strong driver. If you take photoperiod out of the picture, some of these other things may be affecting intensity. Other things are important as well. So if photoperiod not being the same, you may see some effects, some other stuff as well, in my opinion. When you look at talking ducks, so we're talking about the difference here. The different things in ducks and broilers mainly that you may see around the world in places is that ducks also use supplemental lighting that's more natural, or like the sun. So a lot of them are open-sided barns around the world, getting that kind of stimulation versus maybe a broiler. A lot of areas of the world are more in a closed side barn that's got tunnel ventilation. Other in the U.S. And I think other places around the world too. Still, we use Amish farmers, so a lot to grow the ducks in the U.S., which is a certain religion that does not group that does not use electricity that is directly to the grid. So they use a lot of kerosene lanterns, and they also use LED lanterns now. They've kind of switched. Some of them started using LEDs because some of the groups are allowed to use batteries, and they're using those. And these give out much different light. They give the kerosene may give similar light to a sun a little bit because it's burning, but these LEDs may be like the LEDs we use, but they also are very different because they're just designed for camping and not necessarily designed for birds. So that's the other thing, is they're using a lot of lights that are not designed for birds um, out there in the industry. So we're just using lights, and again, we're learning that as we go through and the stuff that birds perceive light a lot differently than us. So maybe there's different effects of different types of light that can be affecting them. And so that kind of goes into this graph here. So when we're looking at lighting spectrum, you'll see on this one, the purple line here is what humans see. So if you look at we see a lot of green. We see green light really well. Yellow lights kind of go. We don't really see red light really well. So if you remember that incandescent light bulb, I put the graph kind of went like straight up like a line here. There's a whole lot of red light over here that we don't perceive. But if you look at broilers or chickens in general, that's kind of the greenish light here, line here. You can see that they see over into this area, the blues, they have a blue peak over there, so they see blue. They also see red light much better than us. So they're perceiving that. So when we used to raise birds under incandescent lights, those chickens or ducks or whatever we're raising under incandescent lights are most likely seeing that is more of a red light. While we see it more as a yellow light, they're figuring that as red. Um, so I get a lot of questions on different aspects of my life where people are asking about heat lamp bulbs and things like that for smaller scale stuff. Should I get a red light or white light? And I'm always like, it's the same light to a chicken or a duck or whatever. It's all going to be red. That's what they see, a reddish tinge to that. It's not really going to be one or the other. Not going to be a white light to them anyway. The other thing about ducks is you'll see on here, ducks have a much, we think they see blue light a little better than a chicken. And some of the spectrums here, we see that they see red light possibly a little better, more often, stronger than the chickens do as well. So the different perception there of light between these two species, and that's going to kind of get into the stuff I'm going to talk about. Differences. You also see the UV end of the spectrum where we don't see any of that, but the birds do. And you also see again that in this aspect, ducks see a little, not as much as we do, as much as a chicken does, I should say. So there may be a little less UV sensitivity to them, but they do still see it as well and are able to perceive that as well. So why does that happen? Well, we think about the differences there because of where these birds are coming from evolutionarily. You think of the jungle fowl, there's several different types, but they all coming from out here in Southeast Asia, living in jungles with dense foliage. They're not getting necessarily direct sunlight. It's being filtered through foliage. So their evolution of their eyes is built for that type of light, for a light that's been filtered, that sunlight that's being filtered down through a dense forest canopy to be able to perceive, find their prey, avoid predators, find mates, do all the behaviors that a wild jungle fowl would be doing out there. So while our chickens have been domesticated for very many years, they're still going to have some characteristics of that going on. And that's a very different ecology from a duck. Ducks come maybe from the same area of the world, but we think that the Peking duck's the main meat duck that we use around the world. It comes from the Muscovy duck. I'm not from Muscovy, from the mallard duck. And those ducks are going to be more in grasslands, marshlands, more open area, where they're going to not have that light possibly filtered as much. So their eyes have been evolutionarily developing for a different type of light than say those chickens have been. And also, I think it's very interesting that Karen said sees differences between her broiler data and her turkey data, because I think that's also another thing, because the habitats of those birds are also evolutionary different. So we can see that it's not just, we can't just say birds are birds. We have to really look at the type of bird we're talking about. And when we're talking about lighting, we can't just say, oh, we think all production birds should be raised under this type of lighting, under this type of photo period, under this intensity, all those different things, because of the fact that evolutionary, they're coming from different places and their physiology has developed over eons differently. Even though we've domesticated them and we may have altered that still some more, we need to kind of think of that too. The other thing about, I'm not going to talk a lot about in ducks today, is ducks are a migratory species more than obviously a jungle fowl. So you need to think about that as in terms of when we're talking about, I'm not going to talk about breeders and things like that, but as they get mature, we need to think about changes in light and things like that. How are we affecting them? Because obviously a migratory bird is affected by light much differently. They get different cues to their brain about if changes start happening in the light, and it changes their behaviors and their physiology and things like that. So we need to think about that as well when we're talking about ducks. When you start talking about breeders and other things like that, if you're going to start changing things. So again, kind of reiterate some of the stuff here. The ecology may explain the difference between them. We don't generally see that, and the knowledge saying that broilers perceive blue light as brighter than red light. They see that blue light more, so that they've developed a greater proportion of those red sensing cones. those red light as brighter than the blue light. So, I mean, sorry, red sensing cones is the blue light sensing. And then, but then ducks, on the other hand, kind of the other way around, they perceive red light as brighter than blue light. So they have greater proportion of the blue sensing cones. So again, we need to think how these birds are different and how it's going to affect. And that's going to be the main difference we'll talk about today, is going to be how they perceive that color of light and how that light is going to affect them. It's going to affect a lot more than, say, as we talked about, maybe some of the photoperiod or some other stuff may not be as dramatic differences between them. How the one thing about ducks to be that with the little bit of limited research out there, there is some evidence that seems to be repeated. We've seen this in my lab. Some other labs have seen this, that excessive blue light is actually seen to be detrimental to ducks, especially the Peking ducks we've looked at. Comparatively, when you look at blue light in a broiler chicken, there's actually seems to be some benefits there. So that's the main difference, is that when we talk to these people when they're trying to adopt things that are in the broiler literature to put towards meat ducks, that it may actually be doing things that are actually detrimental because they're not considering these ecological and physiological differences that have resulted from those ecological conditions of the ancestors. We also talk about LEDs and kind of talk about spectrum. So I'm going to get into spectrum. One of the things we can talk about, again, the spectrum here that I talked about, this is a relatively avian. I believe this is the chicken graph. But you can kind of see this is what the light, again, we see there. Closest you're going to be able to get to that, if you wanted to make a light to mimic this, would be using an LED. They could actually make LEDs if they wanted to. They could make an LED that would be, put out light exactly identical to this in terms of what peaks of light are coming out of it. No one's done that, though, I know yet. Whether that could be good or bad to have mimic that, who knows? But LED, again, can show that again, with the incandescent light bulbs, you'd have just going straight up here, or you're going to get different peaks with the CFL or other different types of light, where this one will at least somewhat, you can somewhat get to the peaks. We can have some blue light in there. You can have certain peaks and not have some of the lights that they don't see. So you're not just putting light out there that they're not even going to perceive anyway. But again, this also comes to us when we're putting light bulbs out there and we're talking about light intensity, we're talking about all these things. Historically, we've done it for us. I know there was a brief mention, and I think the next talk's going to talk about the differential lighting possibly as well. We've historically done lighting how when we're in the barns and what we like. That's probably not what we should be designing at all for any species. It should be what is for those birds themselves, what's going to be beneficial to them for their welfare, growth, things like that, because that's going to be important. And whether it needs to be bright in there for them, as Karen said, that seems to be that dim light is probably not the best thing for most of these birds, but we have done it. But then there's other problems where some of these research out there shows things like certain colors of light may be good, but people don't want to go in there and work. So we get that confounding there, like, well, we don't want to go in there and work under a green light all the time because it hurts our eyes to be in there, but the birds actually like it. So what are we doing? Do we need to have figure out how to manage that process as well? So kind of going to more the circadian rhythm, needs, it functions, keeps the birds going. The clocks are highly complex in these animals, as we talked about with photoperiod a minute ago. The light and neurohormone control secretion of those through the pineal and the retinal melatonin receptors, and that's going to affect their behavior. Melatonin is also very important in their immune function development. A lot of these birds don't have a lot of time to develop an immune system because they're a 6-week-old broiler isn't really immune competent necessarily. They haven't had a lot of time to develop their immune system compared to a laying hen or something like that. Similar with ducks who we raise to 35 days, things like that. They haven't had a lot of time. So any bit of maturation of their immune system that we can help establish and help go along there by having good melatonin rhythms and things like that will help them in terms of disease resistances and things like that, in my opinion. Again, poultry circadian rhythms are going to affect their biology, their behavior, and then the value in the end, what you're getting out of, as Karen said, when you give really long photo periods, you see a reduction in growth, which is going to affect the end dollar there, but it's also affecting their welfare and their behavior, and also their general biology and health in general there as well. So we need to think about how we're doing all our programs here. We've also seen that artificial lighting affects stress, growth, fear, all those things. That's being extensively studied in chickens. So I'm going to start talking about these kind of different things now. Chickens have, as turkeys have a decent amount, as we just talked about there. Chickens, especially broilers, have a ton of research out there for decades and decades on stress, growth, fear response, looking at all different types of stuff. But little research has actually been out there, as I was talking about, on Peking ducks and some other species. So there's not, especially Pekings, we don't have those research. So there, and I'm going to go over the limited research there is out there to kind of show you guys how little that is and why there's definitely a need for more of it, especially as that market starts to grow and we start to raise more ducks around the world. That's going to become more and more of an issue. So again, lighting research in birds is vast and extensive. It goes over intensity, photoperiod, spectrum. There's research out there looking at different ages of birds, looking at how lighting affects them when they're young, looking at chicks to pullets and laying hens, to laying birds, to breeders, to again looking at even within a growing cycle of a broiler chicken, looking at the first during the brood light, then what later what light should be there. But there's even information out there looking at lighting during incubation. I've done a lot of that. There's a lot of information on looking at difference in sex. There's looking at different systems that you're rearing them in, whether it be an entirely closed house, one with maybe windows in it, one with outdoor access. How lighting, there's lots and lots of research out there looking at that. When I did a quick Google search the other day, using just the term broiler chicken and lighting from just the last 24 years, there's over 17,000 results that come back. The one thing I will say about that is a lot of that is based on old lighting technology like incandescent and stuff that isn't necessarily being used right now, or as much, and or being transitioned away from. So while some things like photoperiod may be stronger drivers to a lot of the stuff here, we don't know a lot. So in some aspects, the interactions, maybe in the last 10 years, people have started looking at it more. But when I first started in lighting, we were still doing LEDs were new 10 years ago. So people weren't really looking at LEDs as much, but now it's become more thing. And we just don't know necessarily what's the best LED for a certain thing or what's the best time, and we're still developing new technologies with colors and different things to find out what's going to be the best. So again, while we're basing a lot of our old guides and things and you should use this light or this intensity or this this photoperiod and these things, it may be all, some of it may still be valid, but it also may have some differences there because of the fact that it's, and then the other thing I will say that we always need to be doing new research because while we don't think, as Karen said, a lot of these strains are being necessarily different, we don't necessarily know that's always going to be the case because as breeding companies start breeding for certain characteristics and under certain conditions that they have in their facilities, those may be different facilities than are out there being used elsewhere. So then you may have some differences happening between different breeds, different lines, different birds from around the world for that matter. We're all talking about the major breeders here, but there's some of you who may be having more local breeds out there around the world that may act totally different to different lighting and housing environments because of how you all rear them. But getting the ducks, there's a very limited research, as I mentioned. So there was a review paper done in 2022 by Matt Gunn and Reiber. They looked at basically the Peking duck research that was a welfare research that was out there looking at all different aspects of welfare. And in that publication, they found only 14 publications, and they did a very extensive review that were actually related to lighting in Peking ducks. So for like the entire existence, basically, of research up until 2022, there had been 14 publications related to welfare in duck lighting. And unfortunately, a lot of those were actually done in my lab. So it shows you that there's not a lot of people out there doing duck lighting research, and so that's why again we need more push for that. We need to look into that more. We need to find out as that market grows and that industry starts to grow, and not just rely on the turkey or the duck. The turkey or the broiler research to be our basis for what we should be raising those birds under. So things we're going to talk about today, consider photoperiod, intensity, and wavelength. I'm going to talk about how those maybe differ between ducks and broilers. So photoperiod is the first one we talk about. So the old way of thinking, as you've heard from a little bit in that turkey talk, was constant light was best. A lot of like when I first started in this industry, well, 20 years ago now, everybody was talking about, oh, we need near constant light. We want to have 23 hours of light. We want to give them light. So they're always eating, they're always up and doing stuff. But a lot of research has shown over the years, especially since I've been around the last 20 years, has shown that some of that has been done. Some of the colleagues on here but reduced growth and conversion can be seen with that if you give constant light, and that's due as as Karen mentioned, to the lack of rest. And Richard showed that research that Richard, I was lucky to collaborate with Richard on some of that research there time. But that showed that those chickens are not getting sleep, that other chickens are jumping on them, waking them up. They're not getting good rest because they're moving all the time. That can lead to reduced health and increased mortality, reduce overall animal welfare, obviously in general. So we've seen that over the years. So we realize that dark periods are as important as light periods in poultry. So we need to have dark periods. We can't just say we're going to make them be up 24 hours a day, because I don't like to use a lot of anthropomorphism, but I do this when I teach my students. I say you wouldn't like it either if I made you stay up 23 hours a day, or had the lights on and said you can try and sleep, but all your roommates are going to walk on top of you while you're trying to sleep with the lights on. You would also have all these bad problems. You wouldn't be able to grow. You'd have bad immune function. Your health would go down. You may get so stressed out you may end up dying. Lots of bad stuff would happen to you too. So that same stuff's going to happen to chickens. So we need to kind of think of that as one time when anthropomorphism may actually be relevant, in my opinion. So if we look at broiler recommendations, we look at the Avigen or the Cobb, like two main breeder guides there. They say that you can give 24 hours of light during up to the first 7 days. So that's getting those birds up and moving, learning where the feeders are, the waters are, getting them be active because you want them active. But then they both say after about 7 days of age, you should reduce that light. There's some differences between the guides. Avigen just goes with kind of a blink and give 4 hours of darkness. For the rest of a minimum of 4 hours of darkness, where Cobb's, depending on what you're raising the birds to, what size or age, the endpoint says certain hour ranges there. You can see between 3 to 6 for smaller birds and up to 5 to 10 hours of darkness for bigger birds. And then, so you see there are those changes there. They're mainly saying 4 hours. That generally seems to be the minimum that we're saying. Whether that's the best, I don't necessarily think it may be. You may need a little more. There are typically animal welfare certifications, at least here in the US, and places are requiring at least 6 hours of darkness. And then the European Union requires 6 hours of darkness. So a lot of the research says 6 hours is probably better in broilers. Whether that's true in ducks, we'll talk about that here in a couple minutes there. But the broiler research again shows, this is some old slides, but if I get this thing to go away on the top of my screen, it's blocking my screen. Go away. Can't make it go away. I don't know what's going on with it. Sorry. But as you can see, go back to early on in their lives, that's why the guides kind of go with it. You can see that giving lots of light, giving the more light you give them, up to 21 hours of light, during the first 21 days of light, they grow better. So they will grow better. Whether the welfare is related to that, is questionable. But they will grow better. But as you see after that, research has shown that when you go past that, they don't grow real well but you can see the best growth happens to be around 12 hours of light. And why may that be? That may be because when I talk about the ecology of a chicken, they come from the jungle fowl, Southeast Asia, closer to the equator, is more likely they're going to have we're evolved under 12 hour or close to 12 hours of light, 12 hours of darkness. So maybe that's a factor that's still evolutionary in them, though that's not really possible in most management conditions. You're not going to be able to raise them under 12 hours of light, 12 hours of darkness, just because to be able to make that building light tight in any condition is going to be hard. Even if it's a tunnel ventilated house, the fan ends, when the fans turn on when it's hot, are going to let light in. So you're going to get light into the barn. So it's really impossible to do 12 hours of light. So most of the time we don't do that. We're going to give them where we can manage the light more consistently, than depend on that stuff. But again, this does show the best growth would be they had more naturalistic light. This is just one graphic. I have another guide here showing you for smaller birds, shows similar stuff. Just overall, when you're looking into a 38, when you give them that 4 hours of darkness, they're going to grow the best. When you get past that, they don't grow as well. And you give them too much, they also kind of see it. Too much darkness, they also kind of go down. So there is an optimal time for darkness, again, as that as well. So broiler and welfare-wise, this also comes out of the guy where they've collected data and shows you that too much light actually can lead to mortality and calling due to leg weakness. So you get leg issues if you give too little darkness as well. So when you get out here at the end here, you can definitely see that if you're raising big birds without giving them less light, that you're getting substantially more as the light gets the dark period gets shorter, the more lameness you're having and the more culling due to that. And that also does happen in some of the lighter breeds as well, at lighter ages as well. But you can see they do need darkness. It can affect their welfare, not only just their resting ability, their stress, things like that, but it can actually physically affect their ability to walk and things like that. And that's going to actually affect their ability to eat and become productive as well. So again, a lot of the research and including darkness photoperiod was beneficial, affects their health. Darkness improves productivity, including growth rate, feed intake, feed efficiency. A lot of the research has theorized that the mechanisms behind that could be altered growth curve that affects with that, the increased exercise that they may get in physiological changes associated with exposure to that natural, more regular day-night cycle, and improved immune function may also be related to that. So there are a lot of benefits by giving darkness to broilers. So what about the Peking ducks, the ducks? So the few guides that are out there for commercial birds, I picked this out of one of them, basically says the dark period must be introduced early in the duck's life and able to adapt to darkness. Most easily achieved by running 23 hours of light and 1 hour of dark starting on day 2. So they usually on the first day, they're going to give them constant light, and then the second day, they're going to give them at least 1 hour of darkness. And then from day 7, they say that you have, again, 4 to 6 hours optimized performance. So that means they're giving them somewhere between that 4 hours of darkness and 6 hours of light. Same thing to broilers. So again, this kind of goes to where Karen was talking about. Photoperiod may be pretty consistent in some aspects between species. There may be some differences like between the broilers and turkeys. There may be some differences between ducks and broilers and maybe turkeys as well. But it seems like there's a range there that you need a minimum amount of darkness for all avians to be able to have good, healthy physiology and grow well. You can't just say we're going to give them 1 hour of darkness and that's going to be enough. They need more than that. But what is the research out there? There's not much out there, as I mentioned, in ducks. So the previous reports that have been out there, there was one in 2015 by Erdman. They recommended giving continuous photoperiod in their research, which is confounding to what I just said. But what their research said is they saw they increased body weight and carcinoid. However, there's a lot of welfare concerns with doing that, as I just mentioned. Continuous photoperiod with that implantation, you're going to get things like that increased possibly lameness. You're going to have issues with increased stress and things like that, and poor immune function. All that stuff's going to happen. So Erdman said that again, it's hard to base stuff on just one research. That's the problem with duck research out there right now. We don't really know a lot about a lot of stuff, unfortunately, but because there's confounding stuff in the little bit of research out there. We have a speaker later today who was in my lab at the time, Gabriel House here, actually did a study where we looking at different photoperiods in ducks, looking at 8 hours versus that 4 hour of darkness. We thought, well, hey, maybe if we give them more darkness, maybe it'll be better for them. Maybe we'll get them closer to that maybe natural day light period. What we saw in that case was the fact that giving them more darkness, giving that extra 4 hours seemed to worsen their feed conversion. And also we saw in some stress measures that we did that it actually increased their stress susceptibility, that they seemed to be a little more able to stressed out by those measures. The measures that we collected showed a little more higher stress levels in those birds that get that extra darkness. So again, maybe too much darkness isn't bad for them, but I still believe that giving continuous light to them, like Erdman suggested, is not good for them either. We didn't see a difference in that either between the giving them the extra 4 hours or just a 4 hour darkness period. Any difference in growth. We didn't see any effect on lame or fear response in them really consistently either. So generally the thing you would see in this, we seem to see is, again, maybe in stress measurements, but basically how they're converting the feed that they're eating. It didn't really affect the overall growth. They all kind of compensated to have similar growth rates. Again, ducks just grow really well. So it's sometimes really hard to affect them in terms of what their end growths are going to be. But again, the research out there is very limited in photoperiod. Photoperiod probably needs to be investigated a whole lot more in ducks because I don't think it's going to be, it may be similar to a broiler, but it also may be different again because of the where they evolved from, where ducks do things like fly at night, and they do things when they migrate and things like that. So they may have different abilities to have maybe a longer dark period. So maybe 4 hours is too much, but we don't know because no one's really done any research out there to look at that, unfortunately. So there's relatively limited knowledge on photoperiods. The broiler chickens appear to be minimally the same. However, too long duck period in ducks may also be detrimental to them as well. Or note again that broilers and ducks behave differently, as I just mentioned as well. So they may need similar day length. Like overall, their activity may be different during the daytime. Ducks do a lot about feeding, um, a little more comparatively somewhat to a broiler chicken. They bout feed. They're a little more active. They're a little more flighty. There's a lot of different things that can affect them during their activity. They do different behaviors. Obviously, there's a lot of push for certain breeds to have water access because they need to have some water where broilers don't. So there's a lot of behaviors that can be affected, and when they may utilize those things during their photo period, we don't really know. No one's really looked at that stuff. So what is important? They need to have certain things there. Like we mentioned, the dong dust period. Is it more important for them to have one so they versus a chicken? I don't know. No one's really looked at those kind of things. The next thing we're talking about is intensity here. So we know a lot about intensity and broilers. There's been tons and tons of research on that. Um, During the brood, generally what happens commercially in the US at least is the brood is greater than 20 lux. So we have really bright light during that brood. And then during the growth period, we dim those lights real down. Again, making it really dark in there. Uh, again, but that's not the way it has to be everywhere in the world. And with different systems, obviously, when they're going outdoor access, things like that, they're not going to have that dimmed down as much. The European Union requires much brighter, like 20 lux. Um, why that number? Um, I've talked to some colleagues over the years, and some of them who were involved in making that decision. Some of them have told me that 20 lux was a number that was just picked way back when they were making that ruling for the European Union, kind of out of thin air almost. They looked at the research at the time and they saw having really dim light was bad for broiler chickens. It had lots of negative welfare implications. And then they saw that really bright light was also really bad for broiler chickens. So they picked 20 as a number, even though there was no research out there saying 20 is the best number. They just said, well, we know that way below 20 is bad, and we know that above 50 is bad. So we'll say 20. And so that's kind of where they picked that. So that's where we're at now. Again, that was also based on research done with CFLs and incandescent lights. It wasn't done with LEDs. Um, Again, the reason historically why we've done it, kept those birds at such dim light, is to inhibit their activity, so we get better feed conversion. Um, because we don't want them moving around. We want them eating and resting. We don't want them jumping on top of each other and causing wounds on each other so that they get downgraded when they get to the plant. We want to save energy because incandescent light bulbs were really expensive to run at full intensity, so we want to dim them down. All those problems aren't really there anymore. Because of the fact that we have incandescent light bulbs, we have LED light bulbs now that are very energy efficient. You switch to those or use those, you're going to save a lot of money. So that's not really what we worry about that much anymore. The other thing that I've seen in my research in broilers in terms of intensity is you can raise a broiler chicken in much higher intensity than you can with an LED light than you ever could in an incandescent light bulb. I've done comparison studies. The birds grow just as well as they do under really high intensities with an LED light bulb as they would as a 5 lux dim incandescent light bulb. They don't have their stress levels, their fear levels, their flightiness, all that are all the same under we reared birds of greater than 20 lux under LED, and at 5 lux an incandescent light bulbs, and the birds were the same. But when you raise that incandescent light bulb up to 20, above 20 lux, those birds showed decreased weight gains and more stress and more fear response. So it showed again the type of light may be there because of that incandescent light bulb having a lot of red light. When you raise that bulb up really bright, they're already perceiving a lot of red light out of that, and making so you're making that even brighter in the room by having all that red light with it. Where you have an LED light bulb that you can tell it to not have a whole lot of red light towards one end of it. When you're increasing the light, you're not increasing the red light in it. You're just increasing the other light. So maybe you're not making it as intense for them and stressful for them to be having bright light. And you're making it just brighter for the birds in general, but also brighter so we can see in there, because that is one of the considerations when you're having 5 lux. It's hard for humans to see in there and collect mortality and things like that when you're doing that dim. So again, very low and high intensity have been shown to reduce growth and decrease welfare in broilers. Again, old technology, LED lights have been shown to have much higher, as I just said there. So in the ducks, the guides say that you should read them on even brighter with ducks. They say 40 up to 40 lux during the brood, and then dim them down to 5 to 10. So they're saying brighter in general than broilers. They're saying ducks generally they're raising their ducks under brighter light than they are when we raise broilers under. The daytime low intensity may have negative impacts on mortality, less than that, feed conversion and growth. So they're saying, yeah, if you get below 5 lux, you're gonna have negative impacts on the ducks. Commercial industry out there already knows that, just from what they've seen, even if there isn't published research on it. In addition to low intensities may affect growth, eye growth, as we talked about, increase foot pad lesions, reduce activity and comfort behavior. So you can affect a lot of welfare in the ducks. They know that, so they're saying don't raise your ducks under dim light. Nighttime darkness, the light intensity should be less than 0.4 lux. So that's one of the things we talked about a minute ago. The last talk, Karen was mentioning Richard's research, mentioning the stuff in terms of intensity. That's something we don't really know across a lot of species is what that day-night difference needs to be, intensity. Some of the people out there theorize, and I've theorized over the years, it has to be a minimum of 10-fold difference because like Richard, when I was working with Richard and we saw that stuff, we're putting to 5 lux during the day and 1 lux at night, it wasn't enough to really set up a diurnal rhythm. So it didn't seem like they were really perceiving day night, and it all just seemed the same. So there has to be some greater difference there that they can actually perceive the difference between day and night. Otherwise, there's no point in trying to have a photo period if your light intensities are too close together. So I'm not saying again, like Karen said, that we need to go to complete darkness, because it's naturally, I mean, it's most nights it's not complete darkness. And normally you have moonlight or something out there, so it's not pitch black unless it's cloudy or something like that. So birds generally are getting some light at night. So we don't necessarily, if you do give them complete darkness, from my experience, I'm sure the others can say on here similar stuff. You turn the light to 0. My experience with chickens, especially, is that they all sit down and don't move. So they will go to sleep and stop moving and not walk around if it's completely dark. If you have a light room with no light at all getting in there, they're going to stop all activity and not do anything. But if even they have a little bit of light, they're still going to, some of them are still going to move, and they're going to wrestle around and move around and maybe get up, maybe if you get up and try and eat and drink another night. But again, if they get no light, they won't. But again, that's important there for the intensity thing. So what does the research in ducks say? There's basically none. Again, unfortunately, duck research is so limited out there, but I can go by what I can tell you guys from what I've seen. But one duck study said 5 versus 50 lux showed no difference in live weights. That was in 2022. They saw that, but again, they didn't go below 5. So again, the guides say don't go below 5, but we're saying we could probably raise ducks on pretty bright light, that they're not going to have that detrimental effect that we think maybe happens in broilers, that ducks can probably handle much more bright. And that's the one thing I will say about having bright research or bright light with ducks. And if the light is very bright, you are going to encourage those ducks to eat like crazy, and they will eat more than they normally would if the lights are dim, because the activity is increasing, and they will eat a lot of feed under much brighter light. And of course, because these Peking ducks that are commercial out there convert feed really well. I mean, that you're getting my experience is I can get in, and what the industry sees generally is a 35-day-old Peking duck is weighing around 8 pounds compared to a broiler chicken that's getting to 6 weeks may weigh 6 pounds. I mean, so you're getting huge feed conversions there. They're much better feed conversions. Experimentally, I've gotten down to 1.2 to 1.3 feed conversions in my Peking ducks, so they can really convert feed. So if they eat a whole lot, you're going to get a huge animal pretty fast. If you give a whole lot of bright light, in my opinion. So it really depends on what age you're trying to reach the market. How that light intensity may affect the ducks a lot more, some aspects, than broilers do as you raise that intensity. There isn't any research out there. We haven't done any. Nobody else has done any on how intensity affects other factors like immunity, stress, fear, behavior, lameness, any other welfare indicators. We just don't know. And you're basically the commercial people who have had birds and radio are basically the only ones, they just are what they're doing in-house, maybe with some intensity, and not sharing because they don't want to tell everybody what their trade secrets are. But nobody knows how light intensity is affecting these birds. Like I said, I think they can handle more light intensity than a broiler chicken, just because they're used to being out in brighter light, not being, their ancestors didn't grow up in a jungle that had filtered light. They were out in the grasslands getting more bright light, so they can probably handle brighter light. We just need research to prove that and show that that they can handle way up, and that we don't need to dim their lights, because that's you see in the guide I just mentioned, they're talking about dimming lights for like don't dim below that. That's because people have historically looked at that broiler data and said, well, broilers, we raise broiler under 5 lux, so we should raise ducks under 5 lux. I don't think that's right. You're raising them that's way too dark for a duck. I think ducks need much more brighter light than that. Again, there's extensive research in broilers showing a lot of stuff. There's little research into the broilers. basically are ranging between that 5 and 20 lux out there, sometimes brighter, depending on what system they're in. We just don't know enough about ducks, but it's very important because they are an excitable bird too. It's the other thing. So under brighter light, they do get a little more excitable. So that could be an issue. One thing they may need can handle brighter light, but we need to know what light level is maybe too much. That's making them too excitable. So they're basically running around and maybe injuring themselves or others when you are going in the barns, if they're not used to people and other things like that going in the barn there. So the last thing I'm talking about is wavelength. So extensive research been looking at monochromatic lights and fixtures, cool, warm lights and broilers. Lots of stuff out there in broilers. You may or may not hear in the next talk. I'm not sure what she's going to talk about, but there are a lot of stuff out there looking at different, making wavelength specific lights for broilers and other species. There's been a lot of research out there looking at a cool light versus a warm light. So that means having more yellow in a white light versus more blue. Cool is blue, so having more bluish light in a white light or versus having that more yellow red light in a white light. A lot of research on that, looking at those, what time to do those things on broilers, like saying that you should use warm lights during the brood and cool lights afterwards and things like that. There's a lot of research that says blue-green light monochromatic shows increasing growth. There's even research out there showing that it matters if you're giving blue or green monochromatic at either during the brood or later in life, increases growth, different rates. That research has come out of some researchers out in Israel and other places that have looked at that over the years. A lot of that stuff is out there. There's a lot of monochromatic light, but obviously monochromatic lights sometimes aren't the best lights for people to work under, so that becomes the issue. White light has also been shown, like as I mentioned, that more blue, having that blue, that cool light has been shown to decrease fear and stress. We've seen that in my research, and a lot of other labs have seen that as well. That if you have the more cool light in broilers, it causes them to be calmer, rest more, they grow better, things like that. So it seems to have that blue light seems to be important to a broiler chicken. Broiler chickens seem to really do well with having that blue light. And again, that may relate to the chickens that we talked about when I showed those graphs way back at the beginning of the talk and how they perceive light. We've also done some light looking at UV light, and we've seen that giving supplemental UV light, this is UVA light, giving that to the birds decreases their fear. We said improve immunity, improves growth. So this is a way of trying to make it more naturalistic by supplementing artificial lighting with that. If they're getting out UV light outside or through windows or things like that, then they're maybe already getting that UV light, and that's good. And that should be helping them with their immune function, maybe helping their growth, maybe helping decrease their overall fear. But if they're in a house where they get nothing but artificial light, we've seen if you supplement with UV light, broilers seem to show an improvement with that. So how does it affect ducks? The commercial guide says this. It says currently there's little evidence on light source to affect biological performance on ducks. Lighting must be kept in good working order. Light bulbs replaced required. There's flickering of light, which is negative for duck welfare and affect duck behavior. That's historically on there. I don't think there's been much research actually looking at duck flicker or any of the stuff in general. So as Karen said, we tend to think that flicker is going to be really bad for poultry and that we're going to see really negative stuff. But I found it interesting. She mentioned that in their research that they're publishing that they didn't really see a lot of that bad of stuff as they thought they would in the turkeys. And I'm kind of wondering if you would see the same thing in ducks, that maybe you're not going to see as bad effective flicker on them. But that is definitely a needed area for research that we just don't know about with them as well. But the research that is out there, there's a lot, at least some more on colored lights in ducks than there's anything else. The previous investigations have said that body weight and lower stress corticosterone under red and white light compared to CFLs and compared to CFL, compared to blue CFL. So when you give them blue CFL light, you see birds don't grow well. They have higher stress. Heavier body weights under red light compared to white, blue, and green and yellow ADs. They also saw in this other paper improved feed conversion under red and blue in this one, which is kind of a little different than a lot of other people see with blue light. In this one, they saw some better stuff with blue, in terms of feed conversion. And then they saw they saw long wavelengths encourage peaking duck activity. So again, more of those yellow stuff, you're going to get more activity, yellows and reds, than you would the blues. So you see there's a difference here. Red light seems to be better for ducks. And that may go back to way at the beginning where I talked about how they perceive they have the different perception of cones and rods and cones there, and how they perceive red light different than chickens. That goes on there. Again, with the blue light is an important thing. what's been seen in people in my lab and a few other places that we looked at red and blue light, and we saw that both of those kind of could increase the stress when you give monochromatic light versus the white light. Um, so we did see a little higher levels when you gave that, and that may be because the red light and the blue light were just perceived much. We tried to equalize it by using um, a light meter that does Galilux, so to make the intensities similar. So they should have been relatively perceived. But again, that Galilux is based on the chicken, so maybe different for the ducks. Um, so you don't really know. There was no difference in performance annually, but we did see blue light increase mortality, increase sickness, and reduce through probably reduced immunity, increased stress susceptibility um, as well. So in these blue light, when we gave monochromatic blue light, at least the spectrum that we used, we had substantially more mortality, substantially more birds getting sick with basically bacterial infections. Um, and system and much higher corticosterone levels. The birds were very stressed under blue light. Blue light, in my opinion, is the worst thing to give to a duck. You should definitely be ducks generally seem to be much better under a reddish, yellow, whitish, that hotter light bulb than under any type of one that has that. We also saw that green light, however, could improve growth, reduce fear and stress. We did try some lights under full spectrum lighting, trying to mimic what is out there in the sun. We saw that our full spectrum bulbs that we had were actually worse than using white light and green light. And then we tried using the lanterns, the LED lanterns that they use commercially out there, and we actually saw bad results with those. So those are probably not the best light bulbs to be using, and unfortunately, that's what they are using in the industry. We saw much increased fear and stress and poor growth in those birds comparatively to white and green lights. So again, while they're trying to do it, they're trying to use a technology. We can use LEDs instead of using a flame, which is in our barns. Those LED lights that they're buying are not the right ones for the ducks, in my opinion. So again, that's part of the problem. We don't have researchers tell them and say like, hey, you guys need to have this type of one, and someone needs to develop this type of like portable light for you to have the best growth and welfare for your birds. We've also done some work with LED light similar to the broilers. We saw that did reduce fear and stress and improve their growth. We also saw that eye development could be manipulated, as we talked about, as it was talked about by Karen earlier, that birds' eyes visions can be affected by the growth of their eyes. We haven't really looked into to see if the negative or positive effects, because more research needed that, but I've seen it in broilers, I've seen it in ducks. Different lighting can affect their growth of their eyeballs, and most likely is affecting their ability to perceive their environment. So that definitely needs more research. It's really interesting in the stuff Karen was seeing with the cataracts. Makes me want to be interested in. Karen's still on here. I need to talk to you, Karen, sometime and find out who your ophthalmologist is or what they're doing. So maybe future stuff, I can look at some stuff in broilers and ducks and figure out if that's doing stuff to them. But the results emphasize that UV light and peaking duck housing systems using LED lights, it's moving commercially. Even here where they're using Amish farmers, they are trying to use LEDs. They're moving more towards modern stuff, but we need to know what is actually good for the ducks and not just base it on what we're seeing in other species, because again, we just don't know what spectrum of light. It's probably very different what a chicken needs versus what a turkey needs versus what a duck needs. And that aspect of stuff, because of the fact that they're coming. I mean, it may not be huge differences, but every little piece affects the birds as we're trying to optimize their welfare and optimize their growth. Generally over there, where I said improved growth under blue light in broilers, the big difference is I highlight there is in ducks, the blue light seems to be detrimental to those factors. So it's the opposite between a duck and a broiler. It's the main difference you've seen in the talk today, and we're talking about differences between ducks and broilers, is going to be that wavelength of light seems to be very different, affecting them. Improved welfare, seen both with UV LEDs and LED and UV lights seem to be improve their welfare versus other types of lighting, other types of spectrums of light that have been put out there. So overall, I just want to kind of say there's very little research on ducks. So I only talked about a couple here in Photoperiod, but total there's 3 from what I found over the years. There's 13 on spectrum, and a lot of those are, again, from my lab, 1 on intensity. So we don't have a lot of information to base anything on, but from the little we do see that there are differences, that ducks and chickens are not the same, that we should not be basing the 2 things on each other. What has been done sometimes similar to chickens, but it's not always there. Again, ducks perceive different light than other poultry. Ducks and other domestics are highly photosensitive, so we need to think about all those things, so spectrum, intensity, duration. on validating lighting programs, things like that, because that is going to affect them just as probably as much as a nutrition program or the ventilation program or the litter management. All those different things are all going to be affected. And photo period can actually, and lighting can all affect all those different things. Can affect how well they're utilizing their nutrition and when they're eating. Can affect their litter quality. Can affect how well what they're doing in heat stress. We may be able to mitigate heat stress by changing their photo periods or their intensity of light throughout the day, things like that. But a lot is needed on that. We need a lot more research. The main thing kind of is, and I could have put a picture of a turkey up here too for Aaron, but I think all the birds up here they're just because they're poultry does not mean they see the world the same. They don't see it as the same as us, that's for sure, but they also see it very different than each other. How that light, and there's researchers out there, I know some at Purdue and other places that are looking at stuff, trying to look at perception of light, because how does that light even come into their eyeball and get to their photoreceptors and then through their brain and different things like that? It's very different than probably how light comes into our eyeballs or other species. So we need to really think about how that's all happening there for us to know how to manage them appropriately. So